Okay. All right, guys, here we go. So just to give you a little bit of a heads up, we started chapter 4, if you remember, with section 1, graphing quadratic equations, graphing the parabolas. Do you need a page of notes? Do you need one? So if you remember doing that, that's what we started chapter 4 with, was graphing those parabolas. Then I paused after that quiz and we went into all the factoring. So now that we know how to factor, we're going to go back to chapter 4. I skipped section 2. I kind of snuck it into section 1. And we're going to start back at section 3. Section 3 is solving quadratic equations by factoring. So before we start solving quadratic equations by factoring, I want to show you what you'll be finding when you're solving all of these equations. So guys, if you remember, when we started graphing them at the parabolas, we were graphing parabolas. They either opened up or down. I made you find a whole bunch of stuff. I made you find the vertex, which was that lowest or highest point. I made you find its y-intercept. I made you find its x-intercepts, all that good stuff. So if I gave you a quadratic equation and I asked you to find its y-intercept without looking at its graph, does anybody remember how to find the y-intercept without getting its graph?
Isn't it like m equals
Not m. No, you're thinking of linears. Y? No, that's a line. We're working with quadratics now. We're not doing linear functions anymore. Go ahead.
Negative b.
That's how you found the x-coordinate of the vertex. How did you find its y-intercept? Think about it. How did you find that point without looking at its graph? What do you know, Axel, about that point?
The last.
It is going to be C, but hold on. How would you find it though? X is 0. That's exactly what you had to do. If you want to find a y-intercept, you know his x-coordinate has to be 0 because it's on the y-axis. So we know to find his y-intercept, x has to be 0, and then we can go find out who the y-coordinate is, right? That's how we find y-intercepts. Guys, that's how you always find a y-intercept. When we're in chapter 5, graphing these big degree 3 graphs, you will find its y-intercept by letting x be 0. That's what it has to be. So if we did do that, we would plug in 0, 0 squared plus 4 times 0 plus 3. Some of you already said it. We realized that what number was it always going to be? C, the last number, which was 3. So now you know the y-intercept was the point 0, 3. Now I remember when we took the quiz on graphing quadratics, a lot of you remembered that, and you found your y-intercept, you let x be 0, and you found it. And then a lot of students in all of my classes were like, oh, how do I find my y-intercept? You forgot that x has to be 0. And that is just something that you literally have to imprint in your brain. You have to know that a y-intercept will always have an x-coordinate of 0. So all you have to do is let x be 0 and find y. All right. Well, then I would also ask you guys to find its x-intercepts. But if you remember, when you were finding its x-intercepts, you had to be looking at the graph. You had to find out what x values it crossed over the x-axis at. Sometimes they were whole numbers, and you wrote the whole numbers down. Sometimes they looked like decimals or fractions, and I made you guys estimate or guess. And then sometimes I said, you can't find them, we'll show you later. The reason why I couldn't have you solve for them is, look at how you're going to find an x-intercept. Guys, if I want you to find that point right there, we know his x-coordinate must be some negative number, but who does his y-coordinate have to be? 0. If I wanted to find this x-intercept, I know his x-coordinate must be negative, but what do I know his y-coordinate is? 0. If you're going to find x-intercepts, that means you're looking for x's when the y-coordinate was 0, which means you'd have to go to that equation, let the y be 0 this time, and then solve it for x. Well, guys, you would have to solve that degree 2, that quadratic equation for x. You did not know how to solve a quadratic equation yet, so I couldn't ask you to solve for the x-intercepts. But that's what I'm finally going to be showing you today. Today, I'm going to teach you how to solve this equation. So every time you set an equation equal to 0 and solve for x, you are finding its x-intercepts. So I just want you guys to realize that today. That every time we solve these equations today, you are finding the x-intercepts of its graph. That's what happens when you set an equation equal to 0 and solve. Because we're going to spend chapter 5 finding lots of x-intercepts. So you're going to be setting lots of equations equal to 0 and solving. So I just want you guys to know that when you walk away from today, you know how to find x-intercepts. You're going to set the equations equal to 0 and solve. So if you look at your notes, this is example 1. This is the first equation I'm going to show you how to solve today. All right, but before I solve it, just look at the top of your notes. I just want to, remind you of a few things before we get into the solving. So at the top of your notes, here we go. This is day 1 of section 3, solving quadratic equations by factoring. Guys, a little bit of a spoiler. The reason why the title is not just solving quadratic equations, the reasons it's solving quadratic equations by factoring is because there's going to be other ways to solve a quadratic equation. And I'm going to teach you them, just not in this section. This section is all about solving quadratics by factoring. The higher the degree gets, we're in degree 2 right now, the more complicated they get to solve. So it would make sense that there's more than one way to solve them. So this is not the only way to solve them, but it should be your go-to way to try first. All right, here we go. First, let's review a quadratic equation. A quadratic equation, guys, it's a degree 2 equation that can be written in the form y equals ax squared plus bx plus c. And remember, degree 2 means that the highest exponent on a variable is 2. When you solve all of these quadratic equations today, there will be 2 answers to them. Quadratic equations will have 2 answers, or 2 solutions, or 2 roots, if you will. All right, and then I put a little note here. This is just helpful in math. Whatever the degree of the equation is, it will equal the possible number of answers. So a degree 1 equation will have 1 answer. A degree 2 equation will have 2 answers. A degree 3 equation will have 3 answers, and so on. So the degree is a little bit of a cheat sheet to how many answers you should end up with. It's kind of nice to know that. All right, here we go. The second box. This is the property that we use to solve a quadratic by factoring. So in case you end up seeing this fancy name somewhere, I want you to know what it is. So guys, let me show you first. If I told you that 8 times x ended up equaling 0, who do you already know x had to be? 0. If 2 things multiply to 0, somebody had to be 0. So you know x must have been 0. That's the only way 2 things multiply to 0. If I told you that x times negative 24 ended up equaling 0, who do you already know x was? X must have been 0. Somebody had to be 0 if 2 things multiply to 0. All right, and then there's this one. What if I told you x times y ended up equaling 0? Well, this one has a couple options. Number 1, we know x could have been who? 0. X could have been 0, and y could have been any other number in the world, and this equation would still multiply to 0. Or maybe x wasn't 0, maybe y was 0. And then if y was 0, then x could have been any other number. So in this case, you end up with 2 possibilities, but at the end of the day, somebody had to be 0 if you multiplied to equal 0. And that is the 0 product property. The 0 product property says if a times b equals 0, then we know a or b must have been who? 0. Equal to 0. Exactly. So that's what we're going to use when we solve a quadratic equation by factoring. We're going to use that property. All right? All right, let me give you your list of steps, and then we're going to jump right in. Let's solve that equation. All right. So I've written you some steps in case you get stuck when you're on your own. Now, again, the steps can always sound like, ooh, that doesn't sound nice. But then when you start doing it, it's like, oh, okay, it's not that bad. Step 1, this is how you start every single problem. You have to get everything on one side of the equal sign in the correct order, set equal to 0. So you want every single part of the problem on one side, just put on the table, on one side of the equal sign in ax squared plus bx plus c form, and then you want 0 on the other side. You always want it equal to 0. That's how we're going to be able to use the 0 product property. You want it equal to 0. Then you're going to factor. It's not going away. You're going to factor that problem. You're going to break it up into pieces that multiply. Then you're going to use the 0 product property to set each factor equal to 0 and solve. That's going to be new. We're going to have to get used to that. And then you're going to circle your answers. Then you're done. I just want you to remember that the number of answers should match the degree. So if I give you a degree 2 equation, you should get 2 answers. If I sneak in a degree 3 equation, You should get 3 answers, all right? And then, guys, sometimes you do end up getting the same answer twice. You get like x equals 4 and x equals 4. It counts as 2 answers, but you really only have to say x is 4 once for it to be, like, correct, all right? We call that a double root in math. All right, let's do it. Let's solve the following quadratic equations by factoring. So, guys, here it is. Here's the one from the warm-up. If I wanted you to solve this quadratic equation for x, right, I have to get everything on one side set equal to 0. Is that already done for us?
Yes.
Yeah, it is, right? Oh, Mr. Gold. Everything's on one side set equal to 0. Do you like the order that it's written in? ax squared plus bx plus c? Yeah. It should always have the highest exponent and variable first, and then it should count its way down to the just number. Perfect. All right, so guys, step 1's already done for us. Step 2, factor it. I want you to factor this part of the problem. Break it up into pieces that multiply. Well, guys, who do you always look for first? Does x squared, 4x, and 3 have one? No. So go right to your factors. All right? And now here's where I hope that you guys are getting better and better at factoring, where you're going to be able to do a lot of it in your head so there's not this writing and erasing, because we're not going to stop here. We need room underneath this to solve the problem. All right, so guys, let's see. We know whatever we put in the first 2 spots has to multiply to? No. X squared. And who's our only options? X and X, so we can lock them in. We know whatever numbers we put in the last 2 spots have to multiply to 3. And then our rainbows have to get us 4x. All right. Well, guys, what are the only numbers that multiply to 3? 3 and 1. It doesn't matter where I put them because they're both x's, so throw them in. Now we got to work on the signs. What signs do I need to multiply to that positive 3 and still add up to 4? Positive, positive. Done. Nice. Okay. So now you're like, why the hell do we do that? Well, guys, look at what you are now saying. Look at what the problem says now. The problem says this times this has to equal 0. Well, guys, if this times this has to equal 0, what does one of these have to be?
0.
Somebody's got to be 0. But I don't know if it's this factor who has to be 0, so 0 times that equals 0. Maybe it was this who needed to be 0, so 0 times that equals 0. So now we're going to set each factor equal to 0 and solve for all possible solutions. So guys, maybe it was this factor that needed to become 0. So we're going to take it, we're going to take x plus 3 and find out what does x need to be to make him equal 0, to make him become our 0. Well, guys, you end up with a teeny tiny equation. Minus 3 and x needs to be? No, 0 minus 3 will be? Negative 3. Somebody said negative 3 and somebody said 0, so I just wanted to correct that. So x equals negative 3. So guys, negative 3 is one of your 2 answers. Bless you. All right, but maybe it wasn't him. Maybe this factor needed to become 0. So take your factor, x plus 1, and find out what does that x need to be to make this become our 0. Minus 1 and x needs to be? Negative 1. And those are your 2 answers to this degree 2 quadratic equation. Now let me show you how it works. Guys, let's say x was negative 3. Everybody look at the factored version of this problem. If x was negative 3, what's negative 3 plus 3? 0 times, what's negative 3 plus 1? Negative 2. Guys, what's 0 times negative 2 going to be? 0. He makes the equation true. All right, let's say x was negative 1. What's negative 1 plus 3? 2 times, what's negative 1 plus 1?
0.
What's 2 times 0 going to be? 0. They both make it true. And even if I go up here, I'll just do it with one of them. Guys, negative 1. What's negative 1 if you square him? Positive 1. What's positive 4 times negative 1? Negative 4 and then plus 3. What's 1 minus 4? Negative 3 plus 3? These are the numbers that are going to make that equation true. Those are his solutions. So that means your 2 answers, your 2 solutions, your 2 roots, if you will, are when x are negative 3 and x is negative 1. It also means what x values will his graph cross over the x-axis at? When x is negative 3 and when x is negative 1. Those are the x-intercepts of his graph. And I'm going to show you. I already have it on Desmos. If you look, guys, this is the graph of y equals x squared plus 4x plus 3. Where does he cross the x-axis at? When x is negative 1 and when x is? They are his x-intercepts because that's what you're finding. When you set an equation equal to 0 and solve, you are looking for x When the output, the y value is 0. Those are the x-intercepts, okay? All right, perfect. Let's keep going. So now we got to get into a rhythm. We got to get trained. Let's look at example 2. Let's solve this quadratic equation. Basically, what are his x-intercepts? That's what we're going to be finding right now. All right, well, first, you need everything on one side set equal to 0. Is that done for us? Good. Do you like the order it's written in? Ax squared, bx, and c? Perfect. All right, so now we factor. What are you always supposed to look for first? Okay, now guys, I'm not going to lie to you. If you don't take a GCF out, it'll still factor. I think you're going to work harder to find those rainbows because when you take a GCF out, you're making it smaller and easier to work with. But even if you forget the GCF, it's going to factor. But we're going to take it out. What do they have in common? A 2. So take it out and show me who the new smaller expression is. 2 times what gets you back to 2x squared? X squared. 2 times what gets you back to negative 2x? Minus x. And 2 times what gets you back to negative 40? Minus 20. All right? Now, like always, we'll bring the GCF down. We'll try to factor this again. All right, when I go to factor it, we know what times what gets us x squared. Lock them in. We know whatever numbers we put here have to multiply to who? Negative 20. And our rainbows better add up to? Negative 1x. So start thinking about it. Think about it. I don't have any numbers in front of my x's to throw off my rainbows. Just think of numbers that will multiply to 20 and maybe add up to negative 1. 4 and 5. In any order, it won't matter because it's just x's. 4 and 5. Anybody know what signs we need them to be? To multiply to that negative 20 and then add up to negative 1x.
Plus 4 and then negative 5.
Done. Beautiful. Okay. Now, absolutely, because if you did negative 4 and positive 5, they would add up to positive 1x.
I don't know why I asked that.
Yeah, but it's okay. No, ask it.
I meant if you flip them.
Oh, no, if you put x minus 5 and x plus 4, you're still right. As long as one parenthesis says this and one parenthesis says that, it does not matter the order.
Right.
Excellent. And you're probably not the only one thinking that. All right, guys, look at what the problem says now. Look at what you've made it say. You are now saying that this times this has to equal 0. Guys, the only way this will multiply to equal 0 if somebody was who? 0. Somebody has to be 0. But we don't know which one. So we're going to find out all possibilities. So this is going to feel weird. 2 is one of your factors. Set them equal to 0. Guys, can 2 equal 0? No. Does he even have a variable with him that we can solve for? So you're not going to get an answer from that GCF. But I always want you checking because some GCFs are going to get you an answer. And I don't want you to forget. The rule is if the GCF is just a number, you're not going to get an answer from him. But if the GCF has a variable with it, then you are going to get an answer from that. All right? Maybe it's this factor who needed to become 0. So what's it going to take for x plus 4 to be 0? Who does x need to be? Negative 4. It's always the opposite of what it was in the factor. So there's one answer to our degree 2 equation. But maybe it wasn't him who had to be 0. Maybe it was this one. What's it going to take for x minus 5 to be our 0? X would have to be 5. And now, guys, some of you factor it and you just write x equals negative 4, x equals 5. You don't even write this part. And I'm okay with that. If you know what to do next, then you just do what you got to do. And those are your 2 answers to your degree 2 equation. Those are your answers, your solutions, your roots. They are also the what of this graph. What are those? His x-intercepts. That's where his parabola will cross over the x-axis at negative 4 and positive 5. That's where his parabola crosses. All right, perfect. All right.
So we're basically just finding the x-intercepts.
That's exactly what you're finding. Anytime you set an equation equal to 0 and solve for x, you are finding his x-intercepts.
Okay.
And that's all we're going to do in chapter 5. We're going to set equations equal to 0 and solve. We're going to find a ton of x-intercepts. If you ask my pre-calc students, that's all they do. They set equations equal to 0 and solve. All right, look at number 3. What the hell? All right. In number 3, just look at everything. You got x squared, you got 5x, x's, you got numbers. Everything needs to be moved to one side of the equal sign, set equal to 0. And guys, that's just standard subtract, add terms from one side of the equal sign to the other. It does not matter which way you move them. I could move everything to the left side of the equal sign, you could move everything to the right side, we're all fine. This is my thinking. I know that when I go to factor, I try to keep the number in front of x squared positive. Because if the number in front of x squared is negative, then I know I'm going to have to factor out the negative when I go to factor, and I don't want to do that. So I try to move things that make that front number positive. So guys, if I moved the 4x squareds over here, I'd have to subtract them, right? What's 2 subtract 4 going to be? You can do it. You can do it. I don't like it. If I moved everything this way, how do I get 2's to move over here? 4 minus 2 would give me a positive 2. So that's how I do it. I'm moving everything left. I'm going to try to keep the number in front of x squared positive. All right, so let's move everything from the right side to the left side. So to make him cancel and move, I'd have to subtract them. And I can subtract them from the other x squareds that are over here because they're like terms. How am I getting negative 5x's to cancel and move over here? Add them. And then I can add them to the other x's, which is actually going to work out nicely. I like that. And then how do you get an 8 to cancel and move? Minus it. And then I can minus it from the other just numbers. Gone, gone, gone. All right. 4 take away 2, that's a positive 2x squared. What happens to negative 5x's plus 5x's? They cancel. There are no x's. Bx is 0. All right, and then negative 10 minus 8 more? Negative 18. It equals nothing's over there, so that's 0. Perfect. What's up?
Yeah, same.
That's fine. Go ahead. We can fix that. All right. So we're good. Everything's on one side. I like the order that it's written in. I got ax squared, no bx's, and c. That's perfect. Now we're going to factor it. What do you always look for first? What does a 2x squared and an 18 have in common? A 2. Take it out. Times, what's it going to leave you with? 2 times what gets you 2x squared? And then 2 times minus 9. Perfect. Okay. Now, let's try to factor it again. So bring your GCF down. Let's try to take this quadratic and break it up into 2 pieces that multiply to equal it. Now, guys, you have 2 options. Number 1, you can go through the motions. What times what gets me x squared? What times what gets me negative 9? And then my rainbow's better rainbow 2. Who's my bx? 0. You can do that. Or, does anybody recognize who x squared minus 9 is? The difference of 2 perfect squares. So if you want, just take your square roots. What's the square root of x squared? XX. What's the square root of 9? 3 and 3. And what signs do I need to multiply to that negative 9 and add up to 0? Positive and negative. And you're done. Okay. So now look at what the problem says. The problem says that this times this times this has to equal 0. The only way this is multiplying to equal 0 is if somebody equals 0. So now we set all of our factors equal to 0, and we find all possible solutions. So guys, 2 is a factor. Set them equal to 0, but do you get an answer from that?
No.
No. So he's not good. Maybe it was this factor. What if x plus 3 needed to equal 0? Then who would x have to be? Negative 3 is one of our 2 answers to this degree 2 equation. And then maybe it was this one. So what's it going to take for x minus 3 to be our 0? Positive 3. And that's usually what happens with the difference of 2 squares. You end up with the same 2 answers, but one's positive and one's negative. And those are your 2 roots, solutions, answers. And they are the what of his graph?
Oh, the x-intercept.
Those are his x-intercepts, which are also his roots. Those are his x-intercepts. It will cross the x-axis at positive 3 and negative 3. All right, I tried to throw a little bit of a curveball at you with example 4. Maybe I can.
A little bit.
A little bit. Okay. First of all, I definitely have things on both sides of the equal sign. We're going to have to change that. But if you look, I have an x to the third, an x squared, and an x. I don't have any like terms, but I also don't have a quadratic. This is a degree what? Who's the highest exponent of variable x? 3. So this is a degree 3, and x to the third is your highest exponent in variable combination. So when we solve a degree 3, how many answers should we get? There's going to be 3 answers to this problem. All right, first things first though, guys. Whether it's a quadratic or a degree 3 or degree 4, everything needs to be on one side set equal to 0. So you have 2 options. You can move these 2 terms over to this side, or you can move the 8x over here. Common sense would say, well, why don't I just move him? The problem that I have is I have to leave the highest powered term in front, and he's negative. So now I know when I go to factor, I'm going to have to pull out a negative sign because it's going to lead with a negative, which it's not the end of the world. I know I can do it. but I try to avoid that. So since the number in front of the highest term is negative, I'm just going to move everything over there. Because if I do that, I will add him and he'll end up positive. And then I don't have to worry about factoring out negatives. But at the end of the day, guys, it really don't matter. It doesn't matter which side you move stuff to. We're all going to end up with the same 3 answers. Yes, Cole? That's a negative 7x to the third. Okay, so I am just choosing, because it's my personal preference, to move stuff that way. So I'm going to add my 7x's to the third, and I'm going to add them over here. I don't have anything to add them to, but they'll end up being positive over there. And then I'm going to minus my 30x squared to cancel it and move it over there. Again, I don't have anything to minus it from, but I can move it over there. All right, so at the end of the day, I end up with nothing and nothing, so that's 0. Equals, on this side, I got to put this in the right order. Who should I put first? 7x to the third, the highest power term. And then who should I put next? Negative 30x squared. And then last should be your, what kind of 8x's? Positive. And now it should be equal 0, but I'm just going to put the equal 0 on the other end because it just makes my OCD feel better. All right, now we're in business. Everything's on one side, set equal to 0, in the right order, we're golden. All right, look for a GCF. What does a 7x to the third, a 30x squared, and an 8x have in common? An x. Now, if you had moved him over here, you would have to pull out a negative x, which is fine. You can do that. I tried to avoid the negative. All right, so I'm taking out an x. And now everything else will stay the same. It's just everybody's losing an x from their term. So this will be a 7x squared, a minus 30x, and a plus 8. Done. All right, let's try to factor that again. I'm going to move up here. Let's try to factor again. All right. We know whatever we put in the first 2 spots has to multiply to who?
7x.
Who's our only options? 7x and 1x. Lock them in. We know whatever we put here and here has to multiply to who? 8. And then our rainbows better get us? Negative 30. So again, this is where I hope you guys are getting pretty good, where you can kind of just guess and check stuff in your head. 2 and 4, 8 and 1, and then you just kind of work your rainbows. So guys, I can see into the math future maybe a little quicker than you. I know that if I put a 4 here, I'll get 28. And if I put a 2 here, I'll get 2. 2 and 28 can probably get me 30, but now I have to make sure my signs will work. All right, what signs do I need them to be to multiply to a positive 8, but add up to negative 30 x's? If you put plus and minus, they'll multiply to a negative. Negative, negative. Okay? And you're good. Again, I'm not really walking you through the factoring anymore, because I hope when I start writing stuff down, you're like, oh, I know how she got that. I know why she put that there. It's not because you know how to factor. I don't mean to like rush through it. It's just I hope you already know why I did that. All right, now we got it. Look what it says. It says that this, I don't even know what you said. This times this has to multiply to 0. Guys, that could only be true if one of them was 0. So set every factor equal to 0 and solve. So guys, your GCF is a factor. So set him equal to 0 and solve. And it's like, oh wait, I don't have to necessarily solve, but can x equal 0?
Yeah.
So that's one of your answers. X equals 0 is one of your answers. So that just means he crosses the x-axis right at the origin. That's one of his x-intercepts. All right, so we got an x equals 0. All right, but maybe it was this factor who needs to be equal to 0. So set him equal to 0. And now find me out what x needed to be. So guys, just normal, good old linear equations. How are you going to get x by itself? You're going to add 2. So then you're going to get, I'm not going to write that down, but if I added 2, 0 plus 2 would be 2. Yes, go ahead.
So just because you have an x as a GCF means it's in
He's going to get you an answer. Every time you have a GCF that has an x in it, you're going to get usually a 0 from him. Okay? And then what's the last thing you're going to do to get x by itself? Divide by 7, and x would be 2 divided by 7. Doesn't divide, doesn't reduce. So there's your second answer, and he's not pretty. It's a decimal fraction, but we've seen x-intercepts that are not whole numbers. And then last, what if he needed to be our 0? What would x have to be to make x minus 4 be 0? X would have to be 4. And that's it. So those are your 1, 2, 3 answers to your degree 3 equation. All right? And guys, I'm telling you right now, if you talk to anybody in upper level math, pre-calc, calculus, they do this all day, every day. They solve equations for X. And a lot of them, if it's a degree 3 or a degree 4, they try to make it a degree 2 so they can factor it and solve it. It's all about, are you okay? I'm sorry.
Oh, yeah.
It's all about your, I gotta get my peripheral vision checked, man. I didn't see Keller. But either way, that's what they do. They do this all the time. They set equations equal to 0. They hopefully get to a point where they can factor it and set your factors equal to 0. All right, I have 2 more little ones that are left, and then hopefully we can stop there. All right, look at number 5. Technically, number 5, he qualifies for a different way to solve a quadratic equation, but I'm not ready to show you that yet. So we're going to still solve him by factoring. All right, let's get everything on one side, set equal to 0. Well, if that's how we do it, I like that 9 is positive. So I'm going to leave him. I'm going to move things to his side. So how am I going to get 1 over? Minus it. I don't have anything I can minus 1 from. He'll just stay minus 1. So what order should I write them in? 9x squared, subtract 1, and now it equals 0. Okay, now we factor it. Is there a GCF between 9x squared and 1? No. So we're going to go right to his factors. And now again, you're either going to go through the motions. What times what gets me 9x squared? What times what gets me negative 1? And then my rainbows, who's my BX here? 0. You can do that. Or, does anybody recognize who 9x squared minus 1 is? The difference of 2 perfect squares. So take your square roots. What's the square root of 9x squared? 3x, 3x. What's the square root of 1? 1 and 1, and you need what signs? Positive and negative. It doesn't matter what order, I always put positive first. And you factored it. So now look at what the problem is saying. This times this has to equal 0. Okay? Somebody had to be 0. Maybe it was the first factor. So let's set 3x plus 1 equal to 0 and solve. What are you going to do first to get x alone? Minus 1. So 0 minus 1 will be negative 1. So now we'll have this. What's the last thing you're going to do to get x by itself? Divide by 3. And x will be negative 1 divided by 3. It doesn't divide. It doesn't reduce. That's your first of 2 answers. All right, but maybe it's the other factor. So set the other factor equal to 0. What's it going to take for 3x minus 1 to become our 0? Well, now you're going to do what with the negative 1? Now you're going to add it, so 0 plus 1 will be positive 1. And then what's the last thing you have to do to get x by itself? Divide by 3, and x will be 1 divided by 3. Does not divide, does not reduce. So now your 2 answers are negative 1/3 and positive 1/3. And like I said, every time you end up with the difference of 2 squares, they should end up with the same answers but opposite signs. All right, last one. This is the best. These are like gifts, and every now and again they pop up. So I want you to be able to get these ones right because they're nice. If you look at this one, right, it's a degree 2, it's a quadratic equation. It's already set equal to 0, so that's done for us. Do we like the order that it's written in? AX squared, BX, there's no C, that's fine. That's the order they should be written in. Who do you always look for first when you go to factor this? Who is your greatest common factor? A 2x. Take it out. 2x times what gets you a 2x squared? X. So guys, do you notice? You didn't get a quadratic. You didn't get an x squared. This is going to be a linear expression. Once you have a linear expression, you're going to be able to set it equal to 0 and solve. It's not going to factor again. This is going to be beautiful. 2x times what gets you? Negative 10x minus 5. Done. If this was an x squared, I'd be like, yeah, guys, factor again. But it's not. It's a degree 1 factor. It's linear. So at this point, the factoring is done. The only kind of factoring you were able to do was taking out that GCF. Now you're ready to set your factors equal to 0 and solve. If this times this has to equal 0, set your factors equal to 0. So 2x might need to be our 0. What are you going to do to get x by itself? Divide by 2, and x is still going to be 0. Again, if your GCF has an x in it, you're going to get 0 as an answer. And then if I set this factor equal to 0, x has to be who? 5. So 0 and 5 are your two answers to this degree 2. So guys, every now and again, the only factoring you can do is a GCF. And then you're ready to set your factors equal to 0. So they pop up every now and again. I want you guys to be prepared for that. I know, it's like a mental workout. All right, so guys, that's how we solve quadratics. I did give you a homework tonight. I only made it 6 questions because I know the factoring still takes time, and now you have to set your factors equal to 0 on top of it. So I gave you 6 questions to practice. It's due tomorrow night at 11:45 on Delta Math. And then there's nothing due tonight because yesterday was a quiz day. So you have nothing due tonight. This homework is due tomorrow. I want to come in tomorrow and just practice this. All right, good job. Guys, this is some of the most important stuff I teach you all year.